Hey guys, and welcome to the school station. Today's video is going to be about elastic potential energy. This is from the AQA GCSE Physics 9 to 1 and it's from the unit Energy and Energy Resources. Today's video I'm going to be talking about elastic potential energy, which is one of the 10 types of energy. This energy has its own formula and you'll have to calculate it during the exam. So today I'm going to be telling you guys about elastic potential energy and how to calculate it. So before we get started, we actually have to understand what is elastic potential energy. So elastic potential energy is basically the energy that is stored when a material is elastic. So any material is elastic if it is able to regain its shape after it has been squashed or stretched. For example, if you have a rubber band and you have an elastic rubber band, if you actually can stretch it and it goes back into its shape as its original shape, then you will know that is elastic because it is able to regain its shape after it's been squashed or stretched. Elastic potential energy is the energy stored inside from the work you do after stretching a rubber band or a spring. So again, what we're doing is that if we basically stretch a rubber band or a spring, the energy inside is basically, the elastic potential energy is actually increasing. So therefore that is the elastic potential energy. So now that we know about what is elastic potential energy and it's stored inside any elastic material, now we're going to be talking about the rules of elastic potential energy, and this is really important to know during the exam. So as I said earlier, all elastic materials have elastic potential energy, and also we have to know that when compressing and extending, chemical energy transfers to elastic potential energy. For example, if I have an elastic band and I basically extend it, I'm actually using my chemical energy from my body and it's transferring to elastic potential energy that was stored inside the elastic band. So when you're compressing and extending, the chemical energy from your body is transferring to elastic potential energy. And last of all, we also have to know that every material has a different spring constant, and it's basically, the spring constant is basically how much springy it is in a way, and every material has a different springy constant, so it has different amounts of elasticity due to the object's nature. And I'm going to be talking about the spring constant later on in the video, so stay tuned. But yes, we have to know that every material has its own amount of elasticity. So now that we know about the rules of elastic potential energy, we can now talk about how to actually calculate elastic potential energy during the exam. So there is actually a formula to calculate elastic potential energy, and this is E with a small e is equals to 1/2 times K times E squared. So K actually stands for the spring constant, which is actually measured in newtons per meter. And E is actually stands for the extension, but E can sometimes be written as X, so it really doesn't matter, but E is actually stands for the extension. And again, I will be talking about these two terms later on. And EE is obviously elastic potential energy, which is measured in joules. So I know that some of you guys may be really confused right now, like what is spring constant, what is extension, and this is why I'm going to be talking to you guys about the definitions of K and E. So K actually stands for the spring constant, and the spring constant is a quantity that specifies the stiffness of a spring. So it's basically about how springy the material is. So for example, in a rubber band, the spring constant could be different to some other material. So the spring constant, every material has its own spring constant according to the object's nature. So spring constant is a quantity that specifies the stiffness of a spring. E is extension, and again, the letter E can sometimes be represented as X in different formulas. You really just have to understand the formula, but the letter E could refer to the compression or extension depending on the question. It is relative to the equilibrium position. So now I'm just going to talk to you guys about this letter. So basically, sometimes during the exam we might get a spring, and the spring can either be, it has its own like spring constant because that's basically its original position, which is the equilibrium position. But then if sometimes in questions they're telling you that it has compressed this amount of meters, or sometimes it may tell you that the spring extended this amount of meters. So it's always going to be different in every single question. And do not worry if you're not understanding it right now, because when we're going to get to the question, you will be understanding. But all you have to know is the letter E could refer to the compression or extension depending on the question, and it's basically the extra amount that the spring or the material goes into. So if the material is usually 2 meters and then it gets compressed, or let's say it gets extended 2 more meters, then that is going to be E, extension. Or if sometimes, let's say you have a spring that is again usually 2 meters, you can actually compress it again 2 meters. So that's going to be E, which is still the compression. So therefore, the letter E could refer to the compression or extension depending on the question. So I hope you guys have understood so far. If not, do not worry. But over here I have a question for you guys to try, because I know that it's going to be super hard, but science is all about trying and, trial and error. So I want you guys to pause this video and try this question. The question is: a spring is stretched 0.2 meters from equilibrium. The force constant K of the spring is 2,500 newtons per meter. What is the potential energy of the spring? So I want you to pause this video and try this. Again, make sure to always kind of maybe highlight or just try to think about what things you have already, and then go on and work it out from the formula. So pause this video right now. Alright guys, I hope you guys have tried out the question. I know that it might be really hard, especially the words equilibrium. I know it may sound a bit hard, but here is the answer for all of you guys who have tried it out. So a spring is stretched 0.2 meters from equilibrium. The force constant K of the spring is 2,500 newtons per meter. What is the potential energy of the spring? So first of all, equilibrium is basically the original position that it was in. So for example, if you have a spring and it's just lying on the table, that is its original position. But then this spring was actually stretched 0.2 meters extra. So someone took the spring and they actually extended it to 0.2 meters more, okay? So that's basically the E, which is, or X, whatever you would call it, and that is going to be the extension, okay? And the force constant, which is the normal position of it, is actually 2,500 newtons per meter. So that's going to be okay, which is already written over here. So it should have been a little bit more easier for you. And we basically also, you can write a half 0.5, because a half is equal to 0.5, and then you can just go on and calculate the potential energy. So a half, I just made it into 0.5 because I think it's a bit more easier to calculate it on the calculator. And then we have K, which is 2,500 newtons per meter. And last of all, the equilibrium is the original position, but the extension was 0.2 meters, so 0.2 squared, and that is equals to 50 joules. So that's going to be your answer. That is the potential energy. So I hope you guys have enjoyed or actually got some help from this video. I know that science is all about trial and error and practicing, so remember to also practice some more elastic potential energy questions. But all you have to remember is that X or E in the formula is just basically the extension or the compression. It's basically the extra thing that is added to the normal position or the original position. So we have learned in this video about what elastic potential energy is. It is basically the energy that is stored in any elastic material. We also have learned the formula for elastic potential energy, which obviously is the formula over here, equals to a half times K times E squared. And we also have learnt to solve questions involving elastic potential energy, but I would still advise you to practice more questions. I hope you guys have enjoyed this video. Give it a thumbs up and subscribe down below, and stay tuned for more free science and maths lessons from the school station. Bye guys!